Alright, so we're going to go through the steps for doing the dot structure in VSEPR for ammonia. First, let's take a look at how many electrons we're going to have to work with. So nitrogen has 5 valence electrons, and the 3 hydrogens have 1 each, so it would be 3 electrons we can work with there. So we have a total of 8 electrons to work with. So I'm going to go ahead and put the atoms together here. So we've got nitrogen, hydrogen, 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 and we're going to need to put a pair in for the bonds, and then we'd want to complete the octets of the atoms connected to the central atom, which would be the hydrogens, but the hydrogens only need 2, so they're good. If we look at the electrons we have in place, we put 6 in place and we have 8 total electrons, so we can put 2 more around the central atom, and we're going to kind of circle those just to remind ourselves that they exist there. Now we're going to go ahead and do the VSEPR. So for starters, we want to figure out how many electron domains we have. So if I look around the nitrogen, there are 4 electron domains around the central atom. 3 that are bonding and 1 that is non-bonding. And so those 4 electron domains, getting as far away from each other as possible, are going to form a tetrahedral. So my preliminary structure here will be a tetrahedral with the nitrogen at the center, and so I'm going to put 2 positions that are on the plane of the paper. I'm going to have 1 that goes back into the paper and 1 that comes out of the paper here. And then, strategically, I'm going to put the lone pair up on the top here, all right, because it's going to help my final structure at the end. And then we'll put the hydrogens on the other positions here, here, and here. Now, since we have a lone pair, we're going to need to do a final structure for this. So I'm going to draw an arrow. And the final structure is going to be basically the structure we had before. And so with my iPad here, I'm going to go ahead and do this in kind of an easy way. I'm going to go ahead and copy all of this except for the part with the lone pair. And so I'm going to tap on that, I'm going to copy it, tap there, paste, and so that would be my final structure. I'm going to want to indicate the bond angles here. So if I pick between these 2 spots here, those 2 bonds, my bond angle here, the normal tetrahedral would be a 109.5 degrees, but since we have the lone pair, above the nitrogen there, they're going to actually bring those angles in just a little bit here to about 107 degrees, and then we would call this a trigonal pyramidal structure. And again, our preliminary structure over here would be a tetrahedral. And so it would be a complete VSEPR problem that we'd want to get full credit for if we were asked to do the VSEPR